Hi everyone. Hello, my name is Nuryn, and I'm in my second year of doing construction management degree. So this presentation slide will be about my experience with this course, as well as highlights from week 1 to 5. With my experience doing this course. So I did this back in my first year, like you guys, in my third term as well. Overall, I really enjoyed doing this course. I had a lot of positivity back then with this course, mainly because I love physics and math. So this course is mostly about physics, math, and theories of building structures. Um, One of the reasons I like doing this course was the lecture. They'll present interesting real life situation in the class during the lecture, and the guest speakers were also very interesting as well. Another reason I really liked doing this course was the lecturers and tutors were very helpful. You can just ask them any questions. They have expertise in this field, so they're able to answer any of your questions or any inquiries that you have about the content of the class or even maybe outside class. Personally, for me, the individual project was a very useful assessment because the lecturer, he gave us like a real life project and we had to apply the the theories that we learned in the class to that assessment. So theories and calculations were applied in the assessment, so it was really, you could see where you need to apply those theories and calculations in that particular assessment. Moving on. So my tips is number one is to focus on the theories and examples in the lecture slides. This would mean you need to understand those theories and understand in a way that you'll be able to explain it to someone else. Secondly, you need to focus on the tutorials. For me, personally, the tutorial sheets were given. They were a major help to me. I was able to understand a lot of it, but I wouldn't be able to do it without the help of the tutors. So they played a really big role in my understanding for the sections of the course. Thirdly, actively ask your lecturer and tutors. For my case, I used to, because in the tutorial class, I was really active in a sense that if they ask a question, I would answer. And most of the time, sometimes the answers won't even be right, but the tutor will explain it to you and you'll understand way better once you get something wrong and then it's corrected by others, and then you'll see it in a different way. Number 4 is master the basic concepts and calculations. When I say this, I mean that you need to strengthen your basic mathematics. So this is really important because throughout the course, you'll be using a lot of math and some of them may be a little bit complicated than usual. But I promise you it's not that complicated if you've had practice and you just try and try again and just get used to the process and the practice of that specific calculations. The last one would be every small detail matters. This is partly because sometimes you would think the units that you use won't matter, but most of the time they do matter because they will impact your final results and the value of the final results. You'll be able to understand and see this in the other tutorials. And okay, for highlights in week 1, I would say converting of units, the standard units are really important because you would need to utilize this throughout the course. Okay, so familiarize yourself with the SI units and their symbols, unit and quantity. So for kilograms, it's kg, meters, it's m, U seconds, so s, newtons, n, and the quantity will be mass, length, time, and force. So for force, as you can see on this slide, force equals to ma, which is mass, which is in kg, you multiply with the acceleration, so meter per second square. Another important formula I would say is the Pythagoras theorem, which is the Fr equals to F square Rx plus F square Ry. When you get the total amount, square root them. So for week 2, the first one would be weight equals to mass times gravitational acceleration, which throughout this course we would personally would like to maintain it to 9.8 or 9.81. So this, you might be thinking, is this formula same with MA? It's pretty much the same concept, but they just use different terms. So for example, W you would assume is the weight of the body, but what you don't know is that it also means that it is the force of gravity exerted on the body. Okay, and the second one is bending moment. So moment, the formula is force times distance. So F is the force. Remember to put it in the SI unit, which is newtons. And D is the perpendicular distance in meters, which is M. So if the movement is clockwise, then the value should be negative. If the movement is anti-clockwise, it should be positive. All right, this is another important basic concept that you need to know is how to use sine, cos, and tan. So if the angle is here and you need to find the sine, just remember that take the opposite value over the hypotenuse value. For cos, it's adjacent over hypotenuse. And the last one, tan, it's opposite over adjacent. On the right, you can see this is a typical graph that you'll find throughout the course. For example, if the angle here is 60 degrees and you need to find the fx component, so you need to take the value of f times cos of the angle, which is 60 degrees here. Same as fy, it'll be f times sine a. Just remember how to use this theory so it'll be easier for you to quickly use the formula. So for week 4, I would say an important formula would be the stress, which is delta here, is equals to force over area. Like I said before, remember to use the SI units, which are N over M square. And aside from this unit, you can also assume it's Pascal, because Pascal is the same as N over M square. So here is just an explanation of A being the area of cross-sectional area of the body, and the delta is the stress induced in the body. The other two formulas that I think that are important is shear stress. You have the single shear and you have the double shear. They're both different because single shear, it will mean pressure over area equals to F over A. But with double, you need to double the area that you use. So instead of F over A, it'll become F over 2A. And lastly, for week 5, these are the 3 major important formulas that you would use for this section. So the first one is dead load. Dead load equals to volume of member times unit weight of materials, and you'll get Kn. The unit weight of materials is normally provided in a table. Same goes to UDL. So live load is area of member M square times with the uniformly distributed load. As I mentioned before, this value would be provided in a table in the tutorial sheet or in the exam sheet. They all come out with the same unit in the end, which is Kn. And lastly is the wind action forces. So this would mean the wind load pressure times with the area, you'll get Kn.